Okay guys, I want to show you all a introduction into what concentration is. This is a PHET simulation. It just shows a lot of good stuff. I'll put the link for it, but it's just got water right here. And that's going to be our solvent, and so I can tell the concentration of that. It's 0 moles per liter. Alright, so I can take out water or I can add water if I want to. Now, what I'm going to do is I'll just take my drink mix. Let's say this is Kool-Aid mix. We'll drop some in there and we can note the concentration. Alright, that's pretty easy enough. We added some solute. That was the drink mix. And so that's the solute per solvent, right? Moles per liter. So if we add some more, we get some more, alright? So that's one way to change your concentration, is to definitely add more solute, right? So that will make your concentration go up. So now what will happen if I add water, all right? Will the concentration go up, down, or stay the same? Well, you might have noticed that it got a little bit lighter, and for sure the concentration went down. Almost doubled the volume, or doubled the concentration, so the concentration went down by half, close to half. So that is not that big a deal, right? So if you add more solute, you get more concentration, and if you add more solvent, you get less concentration. So now, what do you guys think will happen if I take some out? Okay, will the concentration go up, down, or stay the same? It stays the same, guys. You see that? Because it is all dissolved in solution. It's a homogeneous mixture. It's dissolved completely. It's nice about simulations. So it's pulling it all out, and so it's all the same. So remember that if you have a 1 molar acidic solution, and if you take a pipette out, full out, you'll still have a 1 molar solution in there. You took out the same amount of solute and solvent at the same time, provided that it was a homogeneous solution. So now we can actually remove some solvent right here by evaporation. So will that make this concentration go up or down or stay the same? Let's see. Well, let's note it. Let's remove it. Oh, you see, I'm not draining it out. I am evaporating it. So I'm losing solvent, which means that my volume is going down. The solute is staying the same, which makes the concentration go up, right? It becomes more and more concentrated. Very cool. All right, so that one is pretty easy. Now let's start over and let's see what happens when we add too much solute. So the drink mix, we can add quite a bit, but we should get to a point. It's getting darker and darker, and it gets to saturated. All right, so when it's saturated, it is now filling up, and it has too much solute. So any solute added is just going to still stay a solid down at the bottom. So notice that the word saturated is not the word concentrated. Be very careful with that. I wrote a detailed description in your notes. I want y'all to check that out and make sure you read that. But you cannot use the word saturated and concentrated in the same interchangeably. Those are two different things. All right. So even if let's see what happens when we take it out. Is it going to go up, down, or stay the same? Stays the same. All right. Now, if we add some water, what do you think it will happen? Well, the concentration stays the same, but you may notice that the solids are starting to dissolve on the bottom. So once we get back up and we get over that, got over the saturation point, we started to get more solvent, and then the concentration started to go down. All right, so that's what happened there. Okie dokie. Now, one last thing I'll add is you can do more than just drink mix here. Let's do potassium dichromate. Each one of these has its own saturation point. See, I can only add a little bit here. But if I added some sodium chloride right here, this one's going to take quite a bit. All right, it's not making too many colors, but you can see that it's going to go on and on and on and on and on and on and on. Sodium chloride has one of the lowest saturation points. I'm sorry, the highest concentration, or yeah, it takes the most amount of solute to make it saturated. So hopefully that made sense. So I hope that provides some clarity and understanding to that. We didn't get a chance to go over this too much in your pre-AP chemistry class, so hopefully that will help a little bit. All right, have a great day.